equations with one radical. So we have a square root of x minus 5 plus 2 equals 12. And since it contains a square root, this is a radical equation. How do we eliminate the radical so that we can solve the equation? We isolate the radical and then square both sides. So subtract 2 from both sides and we get the square root of x minus 5 equals 10. Now we'll square both sides to get rid of that radical on the left. But does squaring two equal numbers always give you two equal numbers? This is something to consider. If the square root of x minus 5 equals 10, if you square both sides, will they still be equal after you do that? Yes, it does. The problem is sometimes squaring two equal numbers will also give you two equal numbers. Because of this, we must check for any false solutions when we use this method. These false solutions are called extraneous roots. These are extra roots that were introduced because when we squared both sides of the equation, it could make some things equal that weren't equal to start with. The easy example would be if you had a negative 3 does not equal 3, but if you squared both sides, 9 does equal 9. So now let's continue. Squaring the square root of x minus 5 just gives you x minus 5, and 10 times 10 is 100. Adding 5 to both sides, we get x equals 105. Now we must check 105. Checking for extraneous roots, we rewrite the equation, putting parentheses where there was a variable. Then inside those parentheses we put 105. I can't stress how important it is to use this method because it just reduces human error. Now when we continue this, we find that 12 equals 12. X is equal to 105 is a good solution since it checks out and it is not an extraneous root. Equations with more than one radical. The square root of x plus 1 plus the square root of 5x plus 1 equals 6. Now this is more complicated because there's two radicals and there's no way we can get just a single radical on one side by itself. Since we cannot isolate the radicals, we will square both sides and see what happens. So that left side we squared was a binomial. Now you should be getting to the point where you can do that in your head. If you can't, you should write it out to see if you get what I got. But the first term squared would be x plus 1. Then the middle term is twice the product of those two, and that would be the 2 times the square root of the quantity x plus 1 times the quantity 5x plus 1. And then the last term squared would be 5x plus 1. Now that's all equal to 36. But remember, try that yourself to make sure you can do that. Now collecting like terms and subtracting it from both sides, we get 2 times the square root of the quantity x plus 1 times the quantity 5x plus 1 equal to 34 minus 6x. Dividing both sides by 2, we get the square root of x plus 1 times the quantity 5x plus 1 equals 17 minus 3x. Squaring both sides again to get rid of the radical, we get a quantity x plus 1 times the quantity 5x plus 1 equals 289 minus 102x plus 9x squared. So once again we get practice in squaring it in our head. Let's kind of go through that slowly. We're going to square 17 minus 3x. So 17 times 17 is 289. The middle term is twice the product. So the product is a negative 51x. And twice that would be a negative 102x. Plus the last term squared, which would be 9x squared. Multiplying the binomials out on the left, we get 5x squared plus 6x plus 1 equals 289 minus 102x plus 9x squared. Putting everything on the right to keep the x squareds positive, we get 0 equals 288 minus 108x plus 4x squared. Now we can simplify this since they're all divisible by 4. We divide through by 4 and we get 0 equals 72 minus 27x plus x squared. Now we have a choice. We can solve it by use factoring, completing the square, or the quadratic formula. I like to choose factoring first, and it does factor into 3 minus x times the quantity 24 minus x. So then what will make those two terms 0? X equals 3 will make the first term 0, and x equals 24 will make the second term 0. Are these good solutions? Checking x equals 3. So we rewrite the equation, putting parentheses wherever we see an x, and then in place outside those parentheses we put 3. And we see it does work out. 6 equals 6. Therefore 3 is a good solution. Checking x equals 24. We repeat the process, putting parentheses where the x is and putting 24 inside the parentheses. And we see that we get 16 equals 6, which is not true. Therefore 24 is an extraneous solution. It does not work. It was introduced when we did the squaring of equal numbers.